In this video, we're going to look at the maximum and minimum of a function. What a max and min is basically, let's say we have a graph here. And say we had, say, function this. Okay, and between, say, this interval right here, we have both a high point and a low point. What this high point is a maximum value given in an interval, and this low point is a minimum value given in this interval. Now what max and min allows us to do is actually find the max and min values without graphing them. So let's take a function and find its max and min. Say we have, this function here. F of x equals 3x squared plus 5. Over the interval, -1 and 2. Make it a little easy for the first one. First, what we do is find the derivative of this function. Okay, when we take the derivative, the 2 comes down here, multiplying the 3 by 2, which is 6x, and the derivative of 5 is 0. So all we have is 6x. We put this equal to 0 if we're going to find its critical values. What does x equal to make this whole function here equal to 0? 0. So this is our critical value. What a critical value is, say we have another graph here, and this function in this interval. What basically a critical value is a point where it changes and turns directions. So on this line here, this point is a critical value because the graph actually changes function from decreasing to increasing. So what we do with this critical value and the endpoints, the interval, is actually make a table. So we have the critical values on this side and the function on this side. So we have 3x squared plus 5. Say we have the critical values -1 and 2 are our endpoints because that's our interval. And our critical value is 0, so we put them here. All critical values go here in between the intervals. So all we do next is actually substitute them. This is going to be -1 squared, which is 1, times 3 is 3, and plus 5 is 8. And we have 3, 0 squared plus 5. So we have 5 here, and 3, 2 squared plus 5. This is going to be 4. 4 times 3 is 12, plus 5 is 17. So these are your values here. You see 5 is the lowest out of all of these, so that's going to be your minimum value. 17 here is your biggest number, so that's going to be your maximum value. So that's basically how you find your max and min without graphing. We can look at a more difficult problem. Let's find another problem to work out. Alright, let's say f of x equal to x squared plus 5x. Okay, over the interval 0 and 5. Alright, first what we do is find the derivative, which is of x squared plus 5x, which is going to be 2x plus 5. You bring down the 2, it'll be 2x to the 1 power, but we don't need that. The derivative of 5x is just 5, and we're going to put that equal to 0. So we're going to subtract 5 here and 5 here. Divide by 2, divide by 2. So x equals -5 halves. Now, you would think this is a critical value, but look at the interval 0, 5. -5, 2 is before 0. So we cannot use this as a critical value. Since we don't have any other critical values to use, we're just going to use the endpoints. So we're going to make a table again. This is our critical values, or endpoints. We have 0 and 5. And since this critical value is not within this interval, we're not going to use it. So we're just going to use 0 and 5. And we're going to plug that into the function x squared plus 5x. So we have 0 squared plus 5 times 0. This is going to be 0, of course. And then we have 5 squared plus 5 times 5. That's going to be 25 plus, well, 25. It's going to be 50. 0 is our lowest number, so that's going to be our min. 50 is our highest number, and that's going to be our max. And that's how you do max and min.